Hi everyone, Mr. Allen here. Today we're going to run through what we call a Monte Carlo simulation in order to kind of establish this idea of how large of a sample do I need when doing a survey, when doing a study, when doing an experiment to get good results. Now, we sort of already know that the answer is it depends, and it does depend on a number of different things. In this case, however, what we're looking to do is use the Monte Carlo simulation to prove to ourselves that the size of the sample depends on a variety of factors, and we kind of have to figure those things out as we go. So just a quick note on what a Monte Carlo simulation is. Essentially, I'm going to randomly generate a series of numbers to simulate, in this case, flipping a coin, with the idea that if I flip a coin often enough, you sort of assume that over time I'm going to get heads 50% of the time and tails 50% of the time. If I flip a coin 3 times, for example, you won't be surprised if I get heads every time. If I flip that same coin 100 times, you'd be quite surprised if I got heads 100 times. So what we're looking to do is figure out what is that magic number that if I do this enough, I get that perfect balance of 50-50 between heads and tails. So I'm in Google Sheets. You can do this in Excel. You can do this in any other spreadsheet software. But the formulas might change if you're in something other than Excel or Google Sheets. So I'm sort of suggesting stick with those. So the first formula I've written here equals ran between. And it's equals ran between 0, 1. So essentially what I'm doing here is what this is doing is it's giving me values between 0 and 1. And then really just 0 or 1 in this case. If I press Control R, again, this is in Sheets, you can sort of see that number. Well, you can't see it very well because I'm getting unlucky, but that number is changing. It's zeros, it's ones. It's not changing quickly enough to really see noticeably on the screen. If I copy that formula down to several other spots, maybe now if I press Control R, you can sort of see the numbers are changing as I go. And so what I'm interested in doing is figuring out how many of those simulations do I have to run so that what's under the heads and tails column here is even. So this is a formula for counting the ones in column A. So it's equals count if, and then to do that, I'll just sort of show you actually, I type count if, and I can just click on column A and it all goes in there. And I need that to be, in quotes, equal to the number 1. And so that's my number of heads, that's my number of tails. Now, really what would be better for me would be to see how that number compares to the total number. So what is the probability, essentially, of me getting heads versus getting tails? So I'm going to take that same column, and I'm just going to count up the number of items in the column. I'll do that here as well. Oh, bad roll there, all tails. Or bad set of rolls, all tails. And so now what I'm going to do with this in this last box here is figure out the probability or the percentage of the time that the one value is coming up. Okay. So the formula here, just dividing the number of heads I got by the total. This is total flips. So 3 divided by the 6. 3 divided by the 6. So there I actually got my 50-50 chance. So these are the probabilities. These are the percentages of the time that these things came up. But you can see that each time my values change, my probabilities here are jumping around quite a lot. My hope with the Monte Carlo simulation is that it will show me how often something is supposed to happen. So right now it's suggesting that I should get heads about 16% of the time. I know that's not true. If I were to, again, just sort of roll again, now it's saying I should get heads 66% of the time. Again, I know that's not true. So what that's telling me is I haven't done a large enough sample. So I'm going to take the same value, I'm going to copy it, and I can copy it either by just going to Edit Copy or by pressing Control C. And I can either drag this down to fill those spots, or I can kind of highlight holding my shift key and my arrow key and just kind of slide down here. Actually, I'll use a number like 20 and I'll paste into those spots. Oops, I didn't do it. Copy, paste. Now I've got 20 flips. Okay, so I've flipped the coin 20 times. I have 13 heads, 7 tails. And if I regenerate the numbers, Control R, you can sort of see that I'm not still particularly consistent. I got 45%, 40, 50%, 45% heads, 55% heads. I saw a 60 in there at one point. There's a 60 again, 30. And so again, what this is suggesting is I haven't done enough of a sample, a large enough sample, to be consistent. And so I'm just going to keep going. 20 wasn't enough. Copy that. And let's paste it down to 50. And see if in 50 turns, I start to get that consistency that I'm expecting. So again, the purpose of the Monte Carlo simulation is to tell me how probable these things are. Now, because I happen to know that, I'm kind of using it in reverse to test how large a sample size I need to get the likelihood that I know I should have. So 48% of the time I'm getting heads right now. Is that consistent? 32, 38, 46, no, still not consistent. So what that's telling me is for this specific event, I need more than 50. Let's go with 100. And if I do this 100 times, 48%, 52%, 46%, 49%. So I'm getting a lot more consistent now, bouncing around that 50% that I expect. Still not perfect. So let's just see what happens if I kind of go extreme here. Copy this and let's just paste it all the way down to 1000. And if I run this 1,000 times, Control and R to regenerate, you can see that my numbers now are right around, oh, I got as low as 48, 46, but the numbers are pretty consistently in the 50 range, especially considering I was getting 30% and 16% earlier on. So what this is telling me is it took about 1,000 flips of a coin before I started to get really consistently close to that 50%. But even then, the 1,000 attempts was probably not quite large enough. And so just to sort of give myself maybe a little bit more confidence, I'm going to insert column here. Oops, didn't mean to do that exactly, but. And so how about I just give myself twice as many of these things. And now I'm going to count up everything in column A and column B to see if it's a 1. Count up everything in column A and column B to see if it's a 0. And count up, again, both columns entirely so that I'm dealing with the number of flips that I've simulated. And now my numbers are, again, a little bit more consistent. Haven't seen anything over 52, haven't seen anything under 48. So at 2000, I'm getting a pretty consistent reading for my values. So what you're going to do now is do the same simulation, but with rolling a die. So you're going to need to get 6 values here. Probably values 1 through 6 make sense. Ran between 1 to 6. You're going to have to generate enough that you get consistent values for counting your 1s, counting your 2s, 3s, 4s, 5s, and 6s. So you're going to, instead of having heads and tails, have number of 1s, number of 2s, 3s, 4s, 5s, and 6s. Your count if will be very similar. You're going to count if whatever the columns are that you've got your information in equals 1. Whatever the columns are that you've got your information in equals 2, 3, 4, 5, and so on. And you're going to want to generate enough values, enough columns worth of values, because it will be thousands and thousands and thousands of values, that you get a consistent value between your 1s, 2s, 3s, 4s, and 5s, and 6s. Because hopefully you understand and recognize that when you roll a die, your chances of getting a 1, a 2, and so on should be the same. And so the idea is you're now going to generate those sort of random numbers 1 through 6 in order to figure out how many simulations, how many of these ran betweens do you need in order to consistently get values that are pretty close between 1, 2, 3, 4, 5, and 6. Obviously, if you have questions, you can ask them. We'll sort of clear this up as we go. But I think it's an interesting exercise in order to kind of just get the feel for how the sample size changes depending on questions and depending on various factors.